Hey everybody, this is Alex Merced from alexmercedcoder.com. In this video I wanted to do is just do a quick discussion of TCP, HTTP. The knowledge of this particular lesson can be used for understanding really just like how the internet works, but also to understand what you're doing more if you're doing like back-end development, like what's kind of going on there and front end and whatnot. Okay, so bottom line is this. First, let's just draw some computers. Okay, so we'll just say here's a computer. And here's another computer. Now these computers, whether they're on the same network, different networks, etc., they can communicate with each other. Okay? They can communicate with each other. Now the way they do this is through something called TCP. Okay, which is Transmission Control TCP. Transmission Control Protocol. Okay? So this basically just kind of sets up the actual infrastructure for computers talking to each other. So this is like saying that every computer has this software that listens for requests, and they listen to requests based on ports. So there's actually a number. So imagine like a shipping port where it's one location, the shipping port, but there's lots of different piers where different boats can park. That's essentially what TCP sets up on your computer. It sets up this sort of shipping port, okay? And you have all these piers, which are referred to as ports, okay? And things can arrive and go out these different ports. So there's like port 1 through 65,000. And it's not that there's actually like 65,000 different like spots in your computer. It's just you have to give it like a label, okay? And the label's numerical. And the reason is why it's like 1 through 65,000 is because technically the label is a number that is stored in an 8-bit unsigned integer. What does that mean? Integer just means a whole number. A unsigned just means it's a positive whole number. And 8-bit just means the amount of memory that you can fit it in. So the biggest number, the biggest positive number you can fit in 8 bits of memory is 65,500 something. Okay, so that's all that means. So that means, hey, what port are you in? You're limited by the number that can be saved in that spot in memory, because they're only that's how much memory they're gonna give you to come up with your label. That's really it. Okay, so essentially what happens is you can sit there and say, my computer is listening, receiving communications with other computers on a particular port. Okay, so that's TCP. That's the thing that actually says, okay, every computer has this little like shipping port built into its software that listens for incoming messages. Okay? Now what happens is that how should those messages look like? Again, you know, if someone wrote me a letter and I got a handwritten letter in the mailbox, but it was written in like Punjab, I'd have no idea what it says. It's not a language that I understand. Okay? So for computers to communicate, not only do they have a mechanism, so again, I have the post system that allows me to send letters to other people, but again, if they receive my letter but they don't understand English or Spanish, then they're not going to know what I wrote. It's like, okay, what's that? Okay, so there also has to be a standard for communicating, and that's where HTTP comes in, Hypertext Transfer Protocol. So the Hypertext Transfer Protocol allows the actual message, the text message that's being sent between two computers. This is a standard format, so that way every computer knows that like the text that comes in is going to look a certain way. So you can set up software that kind of like parses and interprets that text that comes in a standard way. So let's show you HTTP request. Let's look up a picture. HTTP request. Because literally an HTTP request is literally just text. So let's see if we can find a good example. Like this is a decent example. Okay, so this is how this is literally the text. When your browser says, hey, take me to google.com, you're sending a block of text that looks just like this. It starts off with a verb. Okay, this is referred to as the method, okay, that your request is. So I'm get, which represents I'm requesting some information. Post represents that I'm sending some information. And there's a bunch of other ones like put, that's generally used for, hey, to imply that I'm updating some information, and delete, that's implying that I'm trying to remove some information. Okay, so see, like I'm saying I'm making a get, that's a type of request, a method, then it's the URL. So I'm making a request to this resource on the designated server, and this is the protocol I'm using. HTTP 1.1, there's HTTP 2. Oops, I didn't want to go there. Take me back. Okay, so that's essentially what this, it's literally, and then afterwards you just have a bunch of other lines that have a key and a value. These are referred to as headers. Okay, so basically it's just one header after another. You can have as many headers as you want. Okay, and it's just basically anything that reads an HTTP message. So it's going to assume the first line is method, URL, protocol. Then it's header, 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 header. And it keeps going to header until it sees a line break. So the minute there's an empty line, anything after the empty line is the body. Again, it's kind of like there's a standard structure to a letter. When you handwrite a letter, like at the top, you write like your return address, and then that's like the header of the letter, and then you have the body, and then you have the signature. In the same way you have a certain structure to how you write a letter, there's a certain structure to doing an HTTP request. This way, again, the software on both sides knows how to read the requests, because at the end of the day, it's just text. So the only way we know everything in really computers is really just text, and all that text is just bytes. The only reason it does anything is because you have software that interprets it, because it comes in a way that it expects it to be structured. So that's cool. So again, this is like the end, what's referred to as the endpoint. It's the end of the URL. So for example, if I was going to alexmercedcoder.com/cheese, this is the endpoint. Anything after that initial slash. Everything before it is what's called the host. So you see that here, the host, www.test101.com. And it's between those things, basically people read the message, and with those things you can kind of determine, okay, like this is the website I'm requesting. Then there's some other headers, and generally there's a header. If there's a body, there's a content length header that tells you exactly how many characters the content is, so that way we can determine like how much of it you've loaded. Because the way the two computers communicate, because you might be sending a huge amount of information, so it's not going to show up in 1 second. Sometimes you're sending megabits and megabits or gigabits of data. So generally it's done through a data structure called a stream. And what a stream does is that it takes whatever you're sending and does it in chunks. So basically the computer that's sending will take this bit of text that it's going to send and maybe send it one line at a time. Okay, so what it does, it opens up a stream and says, hey, here's my stream. And essentially it becomes just like this thing that you can iterate over that's just like one line at a time. As they come in, it just gets added to the end of the stream. Then the computer that's receiving it receives the stream and then handles it one piece at a time. Okay, so and then you code it out saying, okay, every time a little piece comes in, let's start building up this text file and then build the website. So that's just kind of how computers communicate. So that's, again, just to recap, there's TCP, that's the infrastructure, that's the actual like software protocol that allows computers to talk to each other. Now, through TCP, which allows computers to send basically text messages to each other, there's a lot of different ways those computers can communicate. They can send things other than just text messages. I mean, they can send all sorts of different types of text messages that represent different types of standards. Like there's WebSockets, all sorts of things that allows the computer to respond in different ways. When it comes to the internet, they talk to each other through the HTTP standard. Okay, that's, again, messages that look like this. So they're just text messages. The problem is when the URL says HTTP, so if I go to like some website and I say HTTP / blah 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 blah, that just sends the pure text message. It's not secure. So this text is being sent right over the internet. And then hackers who like sniff packets, and which means they can just pull out characters from the internet as it floats around. What they can do is they can maybe piece together the message and get information. So there is something called HTTPS, which is HTTP secure, essentially, which uses something called the secure socket layer. Okay, and what that does is that it just means that like it gets encoded and decoded. So instead of just sending the raw text, you send like an encoded version of the text, and then the other computer receives it, decodes it, and then looks at the raw text. So the raw text is not being sent over the pipeline. Okay, which is why like nowadays you do everything through HTTPS. Most browsers will kind of like warn you and make it really difficult to do things in an unsecure way. And here's just another example. So you can see here it's always the same things. Like the first line is the method, the URL, and then the protocol, and then again you have the headers, and then the body of the request. That's the structure of an HTTP request. So regardless of like as a programmer, regardless what system you use to program, HTTP always looks the same. Like it's the same text. Okay, the browser receives it, and the browser is built to read HTTP requests. But if I'm a developer and I'm developing a back-end application, I'm developing an application to read those requests. Okay, and I'm gonna basically just kind of demonstrate that. Let's see here. So we're just gonna make a quick npm init -y, just make a quick Express project, npm install Express, okie dokie, and then let's make a server.js, and let me just get this going. So const express equals require express. Okay, and then we're gonna say const app equals express. Then we're gonna want the server to listen, app.listen. So we're gonna listen on port. Let's actually listen to port 65,000. You can, again, there's up to like that many ports. Okay, and actually that should be a number, not a string. There we go. And again, if you're not a JavaScript programmer, the code itself doesn't really matter for this particular video. But all I'm doing is I'm writing a program that basically says to set up a listener. So I'm setting up my own little peer where messages can come in, and that peer is going to have a number of 65,000. So any messages that come on 65,000, I can send responses to. Okay, and then what I can do is that I can create like a catalog of saying, if this is the request, this is the response. And that's essentially what backend development is. You're just basically saying, if this is the HTTP request, like it's basically all based off that first line. Like if the method and the endpoint match a certain pattern. So let me go back to that other one. The other one was pretty good. This one right here. Like if this and this match certain patterns that I'm looking for, then I want to do something in return. Like I want to return or respond with something in particular. Okay, so I'm going to say app.get, which means it's expecting the get verb like you saw in that snippet. And then so I'm saying if it's a get to slash just means like it's just the base URL. Okay, so essentially when there is no endpoint, like if I go to alexmercedcoder.com, this is considered slash because it's implying that there's a slash at the end of the URL, and that's the whole endpoint. Okay, so that's the root, the main page. Again, this is the host. Okay, but if that's the URL, theoretically, then that's what I mean by slash, the main page. And then here again, in this particular framework, which is called Express, I always have access to the request and the response. And generally every framework you have access to these things in some way or other. But the idea is you have details, the details that come in through that request. So Express does me the favor of actually reading that text and breaks it all down for me. I want to see if I can actually get the raw request text in here somewhere. So can I get the raw request from Express? Is that stored somewhere? Get the raw. No, I don't want. Ooh, maybe this is it. So function is built as a middleware function express. It parses the incoming request payloads into a buffer and is based on the body parser. No, that's not what I want. That just allows me to just get the body as the bytes. Get the raw HTTP request from Express. No, I want the actual raw request. Yeah, I don't think you can. The one is because also I think Node in itself in its standard library doesn't facilitate that. Like it already does the parsing for you in the HTTP module that everything in Node is built on. Node is the runtime for JavaScript that I'm using. But I know like in Rust, I was able to get like this, like the raw request. Like it's just pure, like. And if you want to see that, there's actually like soon I should be releasing a 100 days of Rust and Go series, and on day 17 of that, I will be covering making HTTP servers in Go and Rust, and there I kind of really go deep into the same topic I'm going into now. Okay, so app.get, but basically what I can do, so if I just say rec dot, let's just see, I can see all the rec dot, just want to see if I can see something that actually just has like the raw request, pause, listeners, method, once, path, push, range, raw headers. No, I want the actual thing. Route, secure, socket, stale, subdomains, trailers. Forwarded, accepts, subscribe sets, add listener, app, complete, cookies, destroy, emit, event names. Try to see if I can find something that looks like just the raw message. That's just the HTTP version. So these are all things that are parsed out of that message. So like these are the headers. Well, actually headers would be the headers, but host name, isbog, listeners, method, that would be like the method with its get or delete. Once original URL, that's like the whole URL, but we can get the host, protocol, push, range, raw headers, readable encoding, get it for the proper encoding of a given readable stream. The encoding property can be set to user. No. Okay, I guess it really isn't like. And it's like, again, that's not something you would really need, because this has already kind of broke it down for you. I just want to see if I could show it to you. But here's what we'll do. I will do a response dot JSON, and let's just show you some of these pieces. So like we'll have, and let me just deconstruct them out of the request object. So const equals request. So I should be able to get headers, URL, method, host name. Okay, and you can see that like a lot of these details that we just talked about are there. Okay, there's even technically a body, but there won't be any body because, well, we can set it up with a body. Okay. So here we go. So headers, URL, method, host name, body. Okay. Now let's just run the server. Node server.js. Okay, it's listening on 65,000. Now let's see here. So anytime you type into the browser, like anytime you type here into the browser and hit enter, by default, what you're doing is you're telling the browser to make a GET request to that URL. So if I do this, localhost means your computer. So I have a server running on my computer on port 65,000. So on my computer on port 65,000, I have then there it is. See, there's the headers. So you can see all those headers, except again, they came in as text. Like when they came into my server, they were in this kind of format, okay? But then Express, the framework that I'm using, broke it down, and now I'm just regurgitating it. So there's the URL. That's what would have showed up here. So that's what this part is. Okay, and then here we can see all those headers, host, all that fun stuff. There's the method, get request. Okay. So that's cool. Okay, so we can do that. Now, what I'm going to do is I'm going to change this to app.get. This is just a change of function. This just means all methods. So it doesn't matter if it's a get or a post or a put. That will work. So let me just shut off the server with doing Control C and then turn it back on. And Okay. What I'm going to do now is use this tool called Thunder Client. It's a extension which you can install on VS Code. Okay, so you just look up Thunder Client. Okay, and then you can use this Thunder Client, and now I can be like localhost 6500 or 65,000 actually, and then I can do a post request, and this time I'll actually add a body. So here we have a body, eat brunch. Okay, and then now when I look at the response, so here I'm able to send, and that's what this Thunder Client software is. It allows me to send an HTTP request, not from my browser, but using this tool, which is just sending an HTTP request to this. There's Postman, Insomnia, REST client. There's a lot of tools that do this for you. But that's essentially what it's doing. It's allowing you to write, like, kind of configure your own custom HTTP request so that way you can, like, test out your server. But I can see here, I don't see the body. Why don't I see the body? Oh, I know why. Because basically what happens is that by default, my server doesn't know what to do with the body. It's like, what's this? Just a bunch of text. Okay. So what you need to do is in the code, you have to use what's called a middleware. Okay. And I'll just kind of put it in here. Keep it real simple. Request express Dot Json. I put a comma. There we go. That should do it. Okay. Now all that's going to do is that this is going to run before this, and that's going to just say, hey, I know you put some JSON in the body. Let me parse that for you. So now when I do this request, if I do it again, and see now it catches the body because it knows. Because if we take a look at the headers, like let's see here, can I see the actual requests here? Just like the raw request, I'd like to see that. No, but you can see like what happens is because we specify this one header content type that allows the server that's receiving the message to know like this is JSON and then apply the right logic to it. But again, this is just shows you the point is like we're sending that text back and forth, and all our software on both sides are doing is interpreting the text and then using the text delivered through the HTTP message to do whatever needs to be done. Okay, and then HTTP is just this. It's just a standard way of setting up some text. And you send it between two computers. And that's how the internet works. Okay, there's a lot of stuff that happens from one computer to the next, but essentially what your browser is doing is just sending these text messages, and then it receives a version of that text message back, which may have some HTML, which turns into the website that you see on the screen. And when you download an MP3, that MP3 is just a bunch of text that comes up, but when it's assembled together, another piece of software on your computer can read it and actually turn it into music. Yeah, so that's pretty cool. Otherwise, that's all I really wanted to say. I will see you all later. Have a great day and enjoy. Hopefully this gave you some nice perspective on like what HTTP, TCP is, what is an HTTP request, etc. See y'all later.